The following is from fall 2011 test 3, Math 21 test 3, number 8. Probability of A is 40%, probability of B is 45%, probability of B given A is 20%. Find, part A, the probability of A and B. Now, probability of A and B, let me write it on the side note here, can be seen from two different point of view. Probability that A happened first and then B happened after A, or probability of B happened first times probability of A given B. Okay, you can use either one of those two. Now, of course, depends on the given information. Apparently, the one useful for us is the first one. Okay, that's what I will use. The probability of A times the probability of B given A. That's 40% times 20%, 0.4 times 0.2. 4 times 2 is 8, two different decimal places, that's 0.08, which means this is 8%. Part B, probability of A or B, that's the probability of A plus probability of B minus probability of A and B. Now, please be aware that these two events, A and B, are not independent. At least you know that right away, because the conditional probability is different from the regular probability. Okay, so they are not independent. Okay, now I have students who, when they work on this one here, they disregard the given A. They just say probability of A times probability of B. That is only true if these A and B are two independent events, which is, as I said earlier, it is not. They are not independent because the probability of the conditional probability of B given A is different from the probability of B without the conditional. They're different. Okay, which means A and B are not independent. Okay, now let me continue for part B. There will be 40% plus 45% minus 8%. You will see that's 77%. Okay, part C, probability of A given B. Hold on. The one we have is probability of B given A. Right now, we need to reverse the order. Let's use the formula first. This is the same thing. Probability of A and B, right? Big over the probability of B by formula, right? And according to what we have from part A, the top is 8% and the bottom is 45%. That's 0.08 over 0.45, which if I use my calculator, I get 0.17778. Yeah, I round it to 5 decimal places, or in percentage, that will be 17.778%. Okay, now part D, pretty much similar. That's a probability of B given A, B given not A. That's probability of B and A complement over probability of A complement. Now I think probability of A complement is easy. Probability of A complement equals to 100% minus the probability of A, right? That is equals to 100% minus 40%, that's 60%. The hardest one is actually the top one. What is the probability of B and not A? Okay, that's the one we have problem. But I hope you can see it like this. Now, if we have event B here, part of that is in A, right? Let's say this is B intersection A. Then the one outside of A, so let me try to craft it. Let's say this is my A here. Okay. Now the one in the middle is the intersection of B and A. Now the one here is the B and not A. I hope you can get that one. In other words, event B is built on the one intersect with A and the one not intersecting with A, right? In other words, the probability of B and not A plus the probability of B and A equals to, if you take a look on that picture, this equals to probability of B. Okay, now we already know these two here, so probability of B intersect A complement plus the probability of A and B is 8% equals to probability of B, which is 45%. Then probability of B intersect A complement will be 37%, right? So we now have all the building blocks necessary for that question. That's 37% on the top over 60%, right? And decimal 0.37 over 0.6. If I use calculator, I will get 0.61667, or it is 61.667%. Okay, now part D is actually the new question, you can say, that is different from my previous test, that requires a better understanding in your probability. Now this is from fall 2011, Math 21 test 3, number 8.